All right, let's go ahead and knock out the 5-5 even homework problems. 413, 25 through 120 every fifth. So first even would be problem 30. We want to use a double angle formula to rewrite the expression sine x cosine x. All right, so let's go to our double angle formulas. And I'm going to scan down them. And I see this one. Sine of 2u is equal to 2 sine x cosine x. And so we want to use a double angle formula. All right, check. That's one of these. And we want to rewrite this. So we want to have just this on one side of the equation. Well, that's this right here. So we're just one step away. We've got to divide by 2. And so we'll have sine of 2u over 2 equals sine x cosine x, which is what we want. So that's our answer, sine 2u over 2. Now notice that we cannot divide the 2's and end up with sine u, because this is sine 2u kind of as its whole entity. All right? And so if we were dividing by 2, we would need a 2 on the outside, which doesn't exist in this problem. So we don't get to divide away the 2. All right, let's see what 40 is looking for. We want to use the double angle formulas again. This time they tell us cotangent u equals root 2. And that pi is less than u is less than 3 pi over 2. This thing here is telling us quad 3. Quadrant 3 we're in there, between 90 and 270 degrees. All right, so first thing we want to know is we want to know about our triangle of u. Cotangent is adjacent over opposite. And so if we do the Pythagorean theorem, let's see, 2 plus 1 is 3. So root 3. So we've got all the sides of our triangle u. Now let's use our formula. So I'm going to go on our chart, find sine of 2u, and find that that formula says 2 sine u cos u. And so now I can just plug things in. The sine is opposite over the hypotenuse, 1 over root 3. And the cosine is root 2 over, sorry, jumped ahead of myself. That's a root 2 right there over rad 3. And we want to be careful here. Kind of forgot to deal with this quad 3 thing. If we're in quadrant 3, what's the x value? Negative. The y value is also negative. So we want to make sure that when we plug in our values, we also are using the negatives. So let's multiply across. Here we've got 2 times 1 times rad 2. So we've got 2 rad 2 on the top. It's a negative times a negative, so that's a positive. And rad 3 times rad 3 is just 3. Can't clean that up at all, so we're left with just 2 rad 2 over 3. All right. I'm going to go ahead and erase this and do cosine of 2u. All right, for cosine of 2u, we've got 3 different formulas here. We can use any of them. I'm just going to use the first one, cosine squared u minus sine squared u. Looks pretty similar to some other formulas we have, cosine squared plus sine squared u. If that was the case, that would equal 1. But in this case, it's the minus, so it's the cosine of 2u. So let's plug in our values. The cosine, again, is negative rad 2 over rad 3 minus, sorry, this is squared, and negative 1 over rad 3 squared. And so if we square a square root, we get 2. If we square a square root, we get 3. And if we square a negative, it is positive. Minus, same thing over here. 1 squared is 1. Rad 3 squared is 3. 2 minus 1 is 1 over 3 for our cosine of 2u. Okay? And that's our answer. And let's go on to our tangent of 2u. Just do it over here with a little bit of space. Tangent of 2u, the formula for that. Let me pause 1 second. I didn't grab the notes for that one. So actually this is a good opportunity looking in the textbook here on page 416 at the end of the chapter has all of the formulas all in one place right here. So I'm going to zoom in here on tangent of 2u, the double angle formulas. And what we've got here is 2 tan u over 1 minus tan squared u. It is 1 minus, isn't it? Let's go look. 1 minus, yes. Tan squared u. All right, so let's plug in. The tangent here would be the flip of rad 2, so it's going to be 1 over rad 2 over 1 minus 1 over rad 2 squared. And let's clean this up. If we remember 1 over rad 2, we should get the square root of 2 over just 2. And those 2's will cancel out. So in the numerator, erase so we have some space over here. In the numerator, we will have rad 2. In the denominator, we will have 1 minus 1 half, or just 1 half. 1 squared is 1. Rad 2 is squared is just 2. And so if we flip that over, we're going to have 2 rad 2 as our answer. All right, let's move along. Problem 50. Tan squared 2x cosine to the fourth of 2x. All right, so we're going a bit outside of the box on this one, but not too bad. So we have a formula for tan squared u. All right, the formula for tan squared u is, and I'll flip you over so we can see it here. Tan squared u, right down there, is 1 minus cos 2u and 1 plus cos 2u. Negative on the top, positive on the bottom. All right, so it's this u thing here that we're going to plug in here and here. And in our case, it's 2x is our u. So when we do the tan part, it's 1 minus the cosine of 2 times 2x, or 4x, over 1 plus cosine of 4x. So that's the first part. We've dealt with the tan squared. Now let's talk about cosine to the fourth. We don't have any to the fourth formulas, but we do have cosine squared of 2x squared. Right? And we do have a formula for cosine squared. The formula for cosine squared is 1, flip you over to it, cosine squared, 1 plus cosine 2u over 2. What's our u in this case? Our u in this case would be 2x from the inside. All right, and that's over 2. However, this whole thing is squared, so we've got to square this whole thing. All right, so if we clean this up a little bit, we've got, from the tangent, 1 minus cosine of 4x over 1 plus the cosine of 4x times, get rid of this parentheses here, times 1 plus the cosine of 4x squared over 4, 2 times 2. Well, look what we got here. 1 plus cosine of 4x and 1 plus cosine of 4x, so those cancel. That's over 4. And so if we FOIL this, this is the difference of perfect squares. We're going to have 1 minus the cosine squared of 4x all over 4. All right, so we've cleaned this up nicely. However, we're not quite done. If we look up here, it says we need our answer to be in the first power. And we've cleaned this all up, but we're still in the second power, so there's more work that we can do. So let me clear some space here. Alright, so we've got 1 minus cos squared of 4x over 4, which is 1 minus, we have a formula for cosine squared, and the formula for cosine squared is 1 minus, is cosine squared plus or minus? Cosine squared is plus, 1 plus cosine of 2u, double this thing, so 8x over 2. And that's all over 4. Do we have the first power? Yes, we do. It's cosine of the first of 8x. So now we just have to go about cleaning this whole thing up. 1 over 4 is a fourth minus 1/2 over 4 again, minus an eighth, minus this negative will distribute in here. Be careful with that. Cosine of 8x over 8. Alright, so we can clean this up. A quarter minus an eighth is an eighth minus cosine of 8x over 8. And we could pull a 1/8 out if we were really being simplifying all the way down, and we would have this as our final answer. 1/8, 1 minus cosine of 8x. A lot of work on that one. Good job if you followed it all the way through. Let's take a look at 60. A little bit easier on this one. 165, and we want to figure that out using the half-angle formulas. All right, so half-angle formulas, what that's saying is what angle divided by 2 gets us 165. So 330 cut in half is 165, so we'll go ahead and do the sine. And instead of writing 165, I'm going to write 330 over 2, just so we remember it's the u over 2 formulas. And so on this one, we're going to do plus or minus square root 1 minus cos of 330 all over 2. And so that's equal to, the cosine of 330 is root 3 over 2 all over 2. Going to clean this up, and we're going to have plus or minus 2 minus rad 3 over 4. Can't do the square root of the top, but we can certainly do the square root of the bottom and get rad 2 minus rad 3 all over 2. And now we need to make a decision whether we're positive or negative. We're doing the sign in 165, so that's in quadrant 2. In quadrant 2, the y values are positive. So we want the positive answer here. So for sine, we'd end up with rad 2 minus rad 3 all over 2. All right, if we look at our formulas for the half-angle formulas, I'll scroll down here to take a look at it. Look at the difference between cosine and sine. They're exactly the same except for a minus instead of a plus. So if we figured out sine, which we just did, we've also figured out cosine. We just want to figure out our sine. So cosine is x, so we'd be minus square root of 2, and in this case, instead of a minus, it'd be a plus rad 3 all over 2 for our cosine. All right, so we can finish this up by figuring out the tangent of 330 over 2. And we'll just use our formula 1 minus cos 330 over sine 330. And if you look at the formulas, there's actually 2 options here. For this one, we've got 1 minus cos over sine right here, or we've got sine over 1 plus cos. And in this case, since I know since I don't want to have a square root in the denominator, I'm going to use the first one because the sine of 330, sine of 30 degrees is a half, so I won't have the square root in the denominator. Could use either one though. So the finished product here, cosine of 330, is going to be rad 3 over 2. The sine of 330 is negative 1/2. And so if we clean this up, we would have 1 divided by negative 1/2 is the same as 1 times 2. So negative 2 plus rad 3 will be our final answer. All right, on to 70 we go. We want to do the exact values for sine of u over 2, cosine of u over 2, and tangent of u over 2. So same formulas we just used. But before we can do anything, we need to know about our triangle. So we've got cotangent here is going to be 3 over 1. So this is going to be the square root of 9 plus 1, or 10. Square root of 10 here. So let's do sine u over 2 is going to equal the square root of 1. And for sine, it's a minus cosine u over 2, which is the square root of 1 minus the cosine there is going to be 3 rad 10 over 10 all over 2, which if we were to clean this up becomes the square root of, what do we got here? 20 is our denominator. So 10 minus 3 rad 10 over 20. And 20 breaks up into 4 and 5. And we can take the 4 out as 2. So 1 over 2, square root of 4 is 2. Square root of 10 minus 3 rad 10 all over 5. And let's go ahead and take a look at this. This is in quadrant 3. From here, in quadrant 3, we are negative, negative, everything's negative, so our answer here is going to be negative for sine. The cosine is going to look exactly the same. It'll also be negative. The x value here in quadrant 3, 1/2, 10 plus 3 rad 10 over 5. All right, I'm going to go ahead and erase this and plug in tangent. Notice that the tangent should be positive because we're in quadrant 3. And our formula looks like this: 1 minus cos u over sine u. And so we've got 1 minus the cosine is 3 over rad 10. So 3 rad 10 over 10. And the sine here is 1 over rad 10. So rad 10 over 10. You know what? I did make a mistake here. We're in quadrant 3, so I forgot to put our negatives in here. So this is going to have to be 1 plus, and this will become a negative on the bottom. That's going to change what we've done in the sine and the cosine as well. So this is going to have to become a minus for cosine, and it would be a plus for sine. So I'll make those changes. All right, so on this one, we can flip this over. The rad 10 over 10 flipped over. We can say 10 plus 3 rad 10 over 10 times negative 10 over rad 10. Cancel your 10s. And so what are we going to end up here? We're going to have, erase this. We'll have 10 plus 3 rad 10 all over rad 10. Can't leave the radical in the denominator. Let's multiply top and bottom by rad 10. And so we'll get 10 rad 10 plus 30 all over 10. And so our final answer here is going to be rad 10 plus 3. All right, I'll pause it here and do another video for the second half.